Okay guys, so this is about pH. First of all, before we start, if you haven't learned those pH equations, stop the video now. There is no point you doing questions about pH unless you've learned the equations. I think there's like 9 of them, so it's not the end of the world to memorize 9 equations. So if you have learned them, first of all, well done. What we're going to do is go through 3 questions, one at a time. And what I'd like us to do after I've finished rambling on for a bit is for you to try a question, so stop the tape in a bit, try a question. Once you think you've done it, start the tape and I'll go through the question and you can see if you had the right idea. And then we'll do the same for 3 questions by the end of the day. So before you do that though, just one little tip. If you've learned those 9 equations, the biggest thing to be able to do is to choose which ones you're going to need. So what I would do is I'd do kind of like a retrosynthesis. I'd look at what the question is asking. So the question is asking what is the pH, and I'd figure out what is my pH equation. pH equals minus the log of H plus. Write that down. Whatever you don't know about that equation, the H plus, you then do another equation to figure that out. And then if you don't know anything about that equation, another equation to figure that out. And then you just work your way backwards. So that'll help you know you've got a correct path to get to the answer, and you're not just kind of going randomly willy-nilly everywhere. Okay. So stop the tape, have a go at the question, and welcome back. So how would I do this question? Well, first of all, what is the question about? Well, it's about phosphoric acid. Phosphoric acid is a weak acid, so I'm thinking to myself, we're going to need the weak acid equation. Let's go through those equations then. So, we're asked to find the pH. pH equals minus the log of H plus. What don't I know about this? Well, I'm not directly told the H plus. So, we need to do another equation. H plus equals. This is where it comes back to realizing what chemicals are involved in the question. We don't have a strong acid, we don't have a strong base, we don't have a buffer, we do have a weak acid, so we're going to use the weak acid equation. That's also, by the way, why it's really important to remember the names of each of the equations, so you'll know when to use them. The weak acid equation is square root of KaHA, but let's apply it to the question. Our weak acid is phosphoric acid, so conc of that. Okay, what don't we know? Well, we know the concentration of this. We're told it directly, so that's fine. We're not directly told the Ka. Well, it doesn't tell us that. So we're going to need another equation to figure that out. And Ka equals 10 to the minus pKa. And we are told that. So can you see how I've set up a series of equations which leads me, if I go in reverse, back to the answer I want. So all we need to do now is feed in the numbers. So Ka equals 10 to the minus pKa, so that's 10 to the minus 5, which will equal 1 times 10 to the minus 5. I now know this. I can then feed that Ka into this equation. H plus equals the square root of Ka, which we now know is 1 times 10 to the minus 5, times by the concentration of my weak acid, which we're told here is 0.05. Bang all that in a calculator and we get 7.071, etc. times 10 to the minus 4. I'm being lazy to save time for the video, so there's more to it than that. Don't round until the very end of the question. Like I said, I'm just being lazy for the video. I now know my H plus. I can then feed that into my pH. pH equals minus the log of H plus, which is going to give me 3.15. And I've lost the mark there. So have a think. Read the question. Where have I lost the mark? Whenever I do past papers, and I do the papers when they come out, I always lose these marks. And it's because it says round to 1 dp. So that's what you've got to do. And it's dead easy to get caught up in the question, but do, once you've done it, just check whether it specifies what to round to. So that's going to be 3.2. Yeah? So to sum up, figure out what the question's asking, pH, come up with a series of equations which will lead you back to that pH based on what you know. And just remember to figure out what type of chemicals you're dealing with, because that will dictate what type of equations you're going to use. Okay? So that is our first question. Stop the tape, have a go at the second question, and then I'll go through that one. Welcome back. So for our second question, this is hopefully you'll find this a fairly simple one. So what are we trying to find out? We're trying to find out the pH. Well, pH equals minus the log of H plus. And what type of chemicals are we dealing with? Well, we've got a strong base. The hydroxides are generally strong bases. So I'm thinking the strong base equation. So I don't know my H plus. How am I going to figure it out using the strong base equation? So H plus equals Kw over, now originally I'm going to say OH minus, but this isn't the whole of the strong base equation. If you've just done the boot camp, you'll know there's a little bit more to it than that. So for a 3 plus metal, OH minus, so for 3 plus metal, OH minus will be equal to 3 times the concentration of your base, in this case the iron hydroxide. Why is that? Well, when your iron hydroxide dissociates, you'll get your Fe3+, don't care, and you'll get 3 hydroxides. Everybody always puts this number in the wrong place. They always put the 3 there. But if you think about it, if I had a concentration of 1 iron hydroxide, my concentration of hydroxide ions would be 3 times that. So my concentration of hydroxide ions is 3 times my base. But this number, my base, multiplied by 3 equals my hydroxide. So that is the correct way round, although intuitively it doesn't seem like that. Either which way, I can now sub this in. So rather than saying OH minus, because we're not told the OH minus, I can say it's going to be 3 times my iron hydroxide concentration. We're told that, we're told Kw, we're good to go. Let's feed in those numbers then. H plus is 1 times 10 to the minus 14 kW. This is on the back of your data sheet, by the way, so I would try and memorize it, but if you do forget, it is on the back there. Divided by 3 times 2, which of course is 6. Bang that in a calculator, and you'll get 1.6 recurring times 10 to the minus 15. I can then feed that into this equation and say pH minus the log of that number, and that comes to 14.8. Okay? So that's the second one. Again, if you stop the tape, this last one's definitely much more tricky. So I've kind of like saved the best or the worst to last. So it might take you a little bit longer to try that. Try and set up your equations first, is a thing I'd say. You're also going to need to do a balanced equation for the reaction that's happening. Okay. So, welcome back. So what we've got here is a titration, and we've fully neutralized our chemicals, because look, we've reached the end point. So that means they've fully neutralized. So we do not have a buffer. Just a little caveat, if we didn't reach the end point, so if I only partially neutralized my weak acid, we would have made a buffer. Because when these two things react, they're going to give me a bit of salt. And this will dissociate to give the conjugate base. So you'll be left with weak acid and conjugate base. Just something to be aware of there. But that's not happened, we've fully neutralized it, so all we're really dealing with is a weak acid and a strong base. So in my head I'm thinking there's going to be one or both of those equations we're eventually going to use. So let's set up our calculation then. Bit of a long one this. So first of all, it's asking us to find the pH. pH equals minus the log of the H plus. We don't know the H plus though, but it's asking us to find the pH of our strong base there. So this is what the question's asking about, the strong base. So if we want to find the pH of the strong base, we need to use the H plus using the strong base equation. Kw over OH minus, but remember from question 2, with a 1 plus metal, OH minus is equal to the base. Because for every 1 mole of base, it's going to dissociate to give 1 mole of OH minus. So they're equal, so we can just say conc of sodium hydroxide. But the conc of sodium hydroxide is equal to moles over volume. Okay, so now we know our conc of sodium hydroxide because we're not told it in the question. We obviously know Kw, 1 times 10 to the minus 14. I now know my conc of sodium hydroxide, but that's not good enough. We need to find our, we need to rearrange this to find the moles of sodium hydroxide. And as it's a 1-to-1 ratio, that will equal the moles of our ethanoic acid. And how are we going to find the moles of ethanoic acid? Well, the moles of ethanoic acid, again, is equal to concentration times volume. So definitely a difficult one, this. We're kind of working our way back from what we know. Don't know that, so we do this equation. Don't know that, so we do this equation. Don't know the conc of sodium hydroxide, so we do this equation. We're told the volume, tells us the volume, but doesn't tell us the moles. So how do we find the moles? Because it's a 1-to-1 ratio. Well, don't know that, so how do we find that? By doing CV. And we are told the concentration and volume of that. So finally, we've reached an equation where we know everything and we can start feeding back. So I'm just going to rub this out to get a little bit of space. So going in reverse, what we're going to have, our moles of, I'll just put meth for methanoic acid, our moles of that, 1.5 times 10 to the minus 2 times 0.025. Bang in a calculator, 3.75 times 10 to the minus 4, which will also be the same moles of sodium hydroxide because of that 1-to-1 ratio in the equation. We can then calculate the concentration of the sodium hydroxide, which was moles over volume. So we've got the moles. It tells us the volume of sodium hydroxide here. Obviously, we need to convert that into decimeters. So that's 0.03. That comes out at 0.0125. Now we've got the conc of this. We can apply that to get our H plus. H plus equals Kw over conc of hydroxide. So that's 1 times 10 to the minus 14 over this. And that comes out as 8 times 10 to the minus 13. Now we've got the H plus, we can do pH equals minus the log of that number, and that comes out at 12.1. So a bit of a beast of a question, that last one. This would certainly be like amongst the harder style questions you'd get. Hopefully you didn't find those too bad though. So to sum up, try and set up your equations beforehand. Definitely think about what chemicals are involved in the question, because that'll tell you which equations are going to come up. And then once you've set up your equations, you can just work back to get your final answer.